Alright, welcome back. In this video, I'm going to talk about the Gershgorin circle. So this video is a part of the singular value decomposition the video series. Alright, so what's the Gershgorin circle theorems? These theorems tells us that where the eigenvalues lies. Okay, so let's see. Let A be an n by n matrix and R sub I denote the circle in the complex plane with the center A sub II. That's the diagonal entry of the matrix A, and we uh, we use this one as the center of the circle Ri, capital letter R sub I. Okay, and the radius is set as the sigma of a absolute value of a sub ij, and then j moves from 1 to n. So simply saying that basically this is the sum of absolute values of entry in the ith row except the diagonal entry. Okay, so um, then we'll see the complex plan. So let me just picturize that statement. So in the complex planes here, so the rear axis on the horizontal axis is a rear axis, and a vertical axis represent an imaginary axis. Okay, and then the from matrix A, uh, we can figure out the diagonal entry. So we use them as a center of the circle, and then we add all of the entry, taking the absolute value in ith row entries, and then take a sum. We use them. We use it as a radius. Okay. Then so Ri gonna be all of the complex numbers such that the you know the distance between that one and the center is less than this, which is the sum of the absolute values of entry except for ith row except ai sub ii. Okay. So then that's then the Gershgorin circle theorem says that the eigenvalues of matrix A are contained within the union of the circle. Okay, so for each row, we can construct the circle Ri, R sub I, and the union of Ri, let's say R. Then eigenvalues of A are contained in that R. Okay, that's the first statement in the Gershgorin circle. The second statement is the union of any k of the circles that do not intersect the remaining n minus k contains precisely k, counting multiplicity too, k of the eigenvalues. Okay, so what that means that, so look at this. If the 4 by 4 matrix, so we got for the circle R1, R2, and 3 and 4. You see that two circles overlap right there. Okay, see here. Then we expect the 4 eigenvalues, right? And then you see that R2 and 4, these two circles do not intersect with the R3 and R1, right? So then R2 union R4 contains precisely two eigenvalues. Okay, so this is example. So matrix A is given as like this, a 4 by 4 matrix, and now we figure out R1, R2, R3, R4. Okay, so to figure out the where approximately where the eigenvalues lies. Okay, so then the we just what diagonal entry 1, 2, 3, 4. That's gonna be center of the radius, right? Okay, and then the radius is gonna be in the first row. The radius is gonna be 1 plus 0 plus negative 1 plus 1, right? Because A1 we don't add the diagonal entry when you take a sum of the all entry in the first row, right? So the radius is going to be 0. So that means R1 is just a point, A11. Okay, so A1 right here. So and then all the entries are real number. So in an imaginary a complex plane, all the center point going to be on the rear axis, right? On the horizontal axis, I mean. So on the R2, going to be the radius going to be what? 2 plus, and then we skip the diagonal entry, right? And then minus 1 plus 1, which is 2. Okay. So repeating this process, we figure out all the radius and then the circle R1, R2, R3, R4, and drawing them, we got this. Okay. So you can see that all of the circles are overlapped. So then the all the eigenvalues will be within that circle, union of this circle. Okay. So then let's find the spectral radius of A. The spectral radius rho of A denoted by rho of the matrix A is that means the maximum of the absolute value of eigenvalues. Okay. So but then what the since R4 has the largest value of the center with the radius 2, so the spectral radius must be within 2 and 6, bounded by 2 and 6. It makes sense, right? So let's prove the Gershgorin circle theorems, but I want to just prove just first statement of the Gershgorin circle. Okay, so this one, eigenvalue A contain the union of the circle. Okay, so now then the first one, suppose lambda is eigenvalue of A with associated eigenvector X. Okay, and then the maximum norm, that one is maximum norm. It is definition of the maximum norm is the maximum of the xi, because x is a vector, so x1 through xn. The maximum of the sorry, this is absolute value. This is, I missed that. Okay, maximum of the absolute value of the entry, it will be the maximum. Okay, which since ax is a lambda x, right? Because lambda is eigenvalue, we assume that lambda is eigenvalue and x is the eigenvector. So ax is equal to lambda x, right? And then that means we can express this one using the sigma. The sigma of aij and then times xj equals lambda xi for each I, right? Because definitely j is moving from 1 to n. Okay, so for each the row of ax, each row of lambda x, we got this equation, right? Okay. Now then, let's say the maximum norm is actually xk. Okay, so it means that absolute value of xk is the largest value. Okay, out of x1 through the xn. So there is 1 actually. Okay, then when I equals k, then that equation, see equation number 1, we apply the k into I. Okay, then we're gonna get this equation, right? So now when I equals k, that equation must be true, right? It's satisfied, I mean. So now then we're gonna there is when j equals k, we got this one, a k times xk, right? We're gonna move that term to the right hand side. Okay, then we got this a sigma of akj and then xj, and the j goes 1 through n, but except for k, because we move the kth term to the right hand side, so we got lambda xk, lambda times xk minus akk times xk. So then xk is a common factor, so factoring it out, so we got this, right? Now we take absolute value. Okay, it's taking absolute value right here. Okay, taking absolute value, right? Then we got this, but this one must be less than or equals sigma of absolute value of akj times absolute value of xj. Why? Because you know the absolute value of sum of the quantities, sum of numbers, must be less than the sum of absolute value of numbers, right? It makes sense, right? Because I'm sure that you understood that. And then cxj is a what? Because xk is the largest value, actually 1, right? And that means xj, absolute value xj must be less than or equals absolute value xk. So You see that f sub xj is less than or equals f sub xk. Actually, this is 1. Why? Because this is a maximum norm. We assume that, right? So this one must be less than, that one must be less than this one, right? Because what? Since this is a less than or equals 1, replacing this one by 1, then that one must be greater than or equals this, right? And the left hand side, the absolute value of lambda minus akk times absolute value of xk, because xk is what? Actually 1, right? Absolute value of xk is 1. So we put 1 into here. So absolute value of lambda minus akk is less than or equals this one. Just prove it done, right? So at eigenvalue must be within the circle, right? The complex plane circle whose center is akk and the radius is this. We can say that. Okay. So that's for today.